Welcome to After 8, Sweet New Features in Java. So I actually changed the title from what I submitted, but it's basically the same presentation. It's just, I thought this was a better title for it. I like to start these presentations by asking you, the audience, some questions. So who here is using JDK 8? Okay, most people. Who's using JDK 11? Okay, less people. Anybody using JDK 12? Ah, okay, 13? Nope, well, yeah, you don't count. 14? 15? Okay, let's go the other way. Anybody using JDK 7? Okay, 1, 2, 3. 6? Okay, a couple of people. Anybody using anything older than 6? Good, okay. It is interesting to see the way that the adoption is going in terms of Java. Because what I'm seeing is that there's still a lot of people using JDK 8, but we are seeing a gradual migration to JDK 11 because of the fact it's the long-term support release. And a few people are the sort of trailblazers who are keeping up with the release cadence, and they're using 13 and 14 as it comes out. So what I want to do in this presentation is really kind of go through everything that's changed since JDK 8 from a sort of technical perspective. And obviously we have to start with JDK 9. I don't want to spend too long on JDK 9 because it has been around for quite a while now, 2.5 years, which is a long time in Java at the moment. But there were a lot of features that went into JDK 9. And the reason for that was that if you ask Oracle, they will tell you that this was the last major release of Java, as in the last release that had multiple years of development work that went into it. And so I borrowed this slide from Oracle. I figured that I used to work for Oracle, so I can borrow a couple of their slides from now on. But it lists all the features, and there's about, I think, 86 on this list. And I don't want to go through all of those, but I just want to briefly touch on the big one, because this is the one that does have an implication in terms of moving your applications from 8 to 11 or later, or 9 or later. And that is the module system. So again, not going into too much detail, but the module system really can be broken into two parts. The first half is modularizing the Java platform itself. And that makes a lot of sense, because if you go all the way back to JDK 1.0, there were 211 public classes that you could use to build your applications in the class libraries. Move to JDK 8, and there's about 4,500 public classes in rt.jar. And I think this is a really good challenge that I give to all the audiences that I talk to about this, which is to try and find an application that would use all 4,500 of those public classes. I don't believe it's possible unless you come up with some contrived example. But this is the problem, because nobody really needs all of those classes in a single application. And because people have added so many things over time, which is really good for us as developers, we don't have to write a semaphore class anymore, we don't have to write an array list class anymore, it's all there for us in the modules. So what we wanted to do was to say, okay, let's separate that up into more logically related units and make it more flexible in terms of the deployment that we could use. And so what they did was they ended up by separating rt.jar into 75 modules. Of those, 24 are for Java SE, so that's the core part of the specification, and it's what you need in order to call something Java. You've got 2 aggregator modules, which are modules that don't contain any packages, but only contain references to other modules. And then there's smart card, which just kind of happened to end up in there because of historical reasons. And 48, which are related to the JDK itself. So all the different bits of the JDK. So this made a lot of sense, breaking up the platform into a number of modules. The second part of modularity was the encapsulation of the internal APIs. Because even though there's 4,500 public classes in rt.jar, there's also a number of classes in there which are not supposed to be used for general development. And Sun and Oracle have always been very clear about this, that things like Sun Misc Unsafe, you shouldn't be using those for general development. Now, I like Sun Misc Unsafe, The clue is in the name. Unsafe. Don't use it. So, has anybody here used unsafe in any of their application code? Nobody. Nobody's used unsafe. Oh, one person in the back there. Okay, good. Has anybody here used any third-party library or framework like Spring or Hibernate or Log4j, anything like that? Yeah. So you have used Sun Microsystems unsafe, you just don't know about it. And what Oracle wanted to do was to turn off access to all of these internal APIs to make code safer, to reduce security risks, and so on. But the feedback was such that they decided that, for the time being, that they were going to leave access available to these things because they didn't want to break backwards compatibility with a lot of things. So when you move from JDK 8 to JDK 9, there may well be some extra command line flags you need to turn on in terms of being able to grant access to these internal APIs, either through importing the packages or through reflective access. Now, the real advantage of the module system from the point of view of building a runtime for your application is that now you can build a runtime that only includes the modules that you actually need. So you can use jlink, which is a command that comes with the JDK now, and you can do something like this. So you say, okay, I want a jlink. I want to tell the jlink command where my modules are. So this is both for the platform itself and also for my application. Then I want to tell jlink which is the sort of main module where my main entry point is, and then where I want the output of this runtime to go. So a directory where it'll write everything to. And jlink will analyze my application, because in this case I've used modules, and it'll say, okay, figure out all the modules it needs, and then create a directory structure that looks exactly like the JDK, has a bin directory, a conf directory, and so on, such that you can then use that to deploy your application. And if you go into the bin directory there and you run Java with the list modules command line parameter, you'll see that we've got java.base, logging, SQL, XML, and a couple of modules for my actual application. And the really nice thing about this is that if you look at the size of the JDK, it's about 340, 350 megabytes in total. By using jlink, and if you take the most simple application and you do things like stripping out the symbol table, you remove the manual pages and stuff like that, you can actually reduce it down to roughly 10 megabytes in size. So really, an order of magnitude less than you have for the full JDK. And that's very good because if you're doing things like microservices where you want to deploy into a container, then you put your runtime in the container specific to that service and you tailor it, shrink it down, only has the modules you need. So this is really the big advantage of the module system for that kind of thing. Okay, now the next thing in JDK 9 is to understand about how there was also cleaning up of the JDK. If you look at the history of Java, lots and lots of things have been added over the years, which is really good. But unfortunately, up until JDK 9, nothing had ever been really removed. So we had deprecation in JDK 1.1, the ability to identify that certain APIs were deprecated, meaning you shouldn't use them or there were alternatives that were better. And I counted up, and there's about 453 deprecated API elements in JDK 8, of which 0 had ever been removed, which kind of says, well, what's the point of deprecation if you never actually remove anything? So, okay, in JDK 9, the OpenJDK developers said, right, we are going to start removing things that have been deprecated. And they didn't exactly go wild, because they removed 6 methods. That was it, 6 whole methods. And you kind of think to yourself, what did those 6 methods do that were so bad that meant they got removed and everything else got left behind? And it turns out that when they tried to separate out the modules and create boundaries between them, there were some very odd relationships between some of the code. And so they removed these 6 methods to make a cleaner separation of the module system. They did also remove a whole class from the Java authentication and authorization service, and they started removing some of the older tools, which people are not really using anymore, things like JHAT, things like the hprof agent, and so on. Now, this continued in JDK 10. They went a little bit further in JDK 10, so one whole package, 6 classes, 9 methods, and 1 field. But still, a gradual thing, which is good because we don't want to just remove everything in one go. If we just took out all the deprecated things, that would cause some problems. And this is going to continue in the future. We've already seen that there are some significant things that have been deprecated. CMS, the garbage collector, was deprecated in JDK 9, and as of JDK 14 next month, it will be gone. There will be no more CMS in OpenJDK. Nashorn, that's also been deprecated. Don't know when that will be removed. PAC 200, compression technology, really used by applets, that's gone as well in JDK 14. I suspect there'll be some other things that will get removed as well. Okay, let's talk about what's happened since JDK 9. JDK 10. Now, this was the first release that only had 6 months of development behind it. So clearly there's not going to be quite as many features as you got in JDK 9 or JDK 8. But there were still some good things here. Let's have a look at how we use local variables in Java. Now this is very typical code that we would write. So we say list of type string, user list equals new array list, and we can use the diamond operator to give us type inference of the generic parameter. We don't have to specify that the array list is a type string because the compiler can infer it from the left-hand side of the assignment. All good. And then we can use something like stream of string when we retrieve the stream from that user list. And we can use variables in a for loop. We could use the more modern style of for each loop and say for string over name, or string name over user list. And we can also use that in a simple for loop where we say int I equals 0, I less than 10, I plus plus. All classic examples of using local variables. In JDK 10, we get local variable type inference, which means now we have var in Java. This is great because JavaScript has var, so it must be good. So we put it in Java. Okay, maybe that's not the right answer, but it does allow us to simplify some of our code quite nicely. And so here's, if we look at those examples, we can use var and say var user list. And that way we don't have to duplicate the fact that we've got a list on the left-hand side and a list on the right-hand side. Very important thing about this, though, is to note that I have added the generic type parameter on the right-hand side. I'm not using the diamond operator, which is what I did in the first example. The reason for that is that if you go through and you refactor your code to use var, and you just go down the left-hand side and you just go var, 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 you might have some problems. Because if you've used the diamond operator, you run into double type inference, meaning that the compiler has to infer the type of the generic parameter, which it can't do because var doesn't give it any information. So it will just assume that object is the type that's going to use there. So if you use the diamond operator, you'd actually get an array list of object rather than an array list of string, and that could cause you problems. So you need to be very careful if you've used the diamond operator to make sure that you put a type in there so that you don't suffer from this double type inference. Similarly, in terms of the stream, the compiler can infer from the fact that we've got an array list of type string that the stream is going to be a stream of type string. So this is all good. Again, we can use that in the for loop, and we can say for var name over user list, and the compiler knows that it's going to be a string, so there's no problem. And then lastly, we could also use it in this case where we could say for var array equals 0, I less than 10. Do not do this. This makes no sense because var has 3 letters. Int has 3 letters. You are not saving yourself anything by using var. You are just making it harder to see what the actual value is. One of the nice things about var is tidying up code and making it easier to read. So I've created a very, it's a slightly contrived example, but it does prove the point. I've got a try with resources block here, and you can see that I've got an input stream, which I'm then getting an input stream reader from, which I'm then getting a buffered reader from. And clearly, by using good variable names, I end up with a lot of repetition. Your input stream equals get input stream reader equals new input stream reader, input stream, buffered reader, blah, blah, blah. Okay, so lots of repetition and so on, which makes it hard to see what's going on. If we use var in this case, then we can simplify things out and it becomes easier to see what's actually going on. So suddenly it's like, input stream reader, buffered reader. Nice, clean code, easier to understand, easier to maintain. All good stuff. There are some interesting edge cases with local variable type inference. So this is code which will not compile using the Java compiler. You can create an inner class, and you can say, okay, object fruit, and I want a new object as an inner class, but I'm going to add some extra things to that. So I'm going to create an instance variable, and I'm going to add a method. Now, that on its own will compile, which I find a little bit odd, but it will compile quite happily. The moment, however, that you try and reference either of those things, the instance variable or the method, then the compiler will go, oh, hang on, that's an object. Object doesn't have a name instance variable. It doesn't have an in French method. So you'll get a compiler error associated with that. If we use var, we can make that code compile. So we simply change the fact that we've got the object there, change it to var, and suddenly that code will compile and it will work. How does that happen? Well, what's going on is that you've got the idea of a non-denotable type. And what happens there is that in the Java language, you have a set of types that you can represent in the actual language. The JVM can understand more types than you can represent in the Java language. So in this case, what the compiler is able to do is to generate, in essence, a synthetic type, which allows the JVM to understand that as a type and therefore use those instance method and the method itself, the instance variable and the method. So you can actually make that work. It's just one of those kind of interesting edge cases. This also can be used in terms of some other things as well, where if you've got multiple interfaces that you want to represent, then you can do the same thing with that. No, okay, that wasn't quite what I intended. Okay, so one of the things that changes in JDK 10 is the fact that var is a reserved type, not a reserved keyword. So that means that one of the things that you could have done in JDK 9, but you never would have done, is create a class called var with a lowercase v. In JDK 10, you can't do that. That won't compile because var is a reserved type. But what you can do is create a var with an uppercase v, which means that you can actually end up with this where you've got var equals new var. And that's perfectly legitimate. You can compile it. It will work quite happily. I probably don't recommend that as a syntax, but you can do it. Few selected JEPs from JDK 10. I haven't listed everything here. I'm just going to kind of talk about some of the highlights that have been included in that. And many of these sort of refer to not just the language itself, but lower level things in terms of the JVM. So one of the things that they've done is to enhance the G1 garbage collector so the full GC phase of that collector now works in parallel. Before, it was only single-threaded, and that reduced the throughput that you could get with the collector. So to improve that, they've made that parallel now, and that gives better performance on G1. Application class data sharing. This used to be a commercial feature in the Oracle JDK. They contributed it to OpenJDK, so now it's part of the open source. What this allows you to do is to improve the startup time of an application, because when you start up your application, the JVM has to read class files that contain the information for your application. To do that, it builds some internal data structures which it uses to represent the classes. When you start the application again, it has to do the same thing, read the classes, build the internal data structures. With application class data sharing, you can run your application and then write those internal data structures out to a file so that when you start it again, you simply map that file into memory, JVM points at it, and suddenly it's got all the data structures it needs, so it starts up more quickly. The other advantage of that is that if you've got multiple JVMs running on the same physical machine, running the same application, then because it's a memory map file and it's read-only, they can share the reference to that and so reduce the amount of resources that are required by all of the JVMs. JDK 10 includes an experimental Java-based JIT compiler called Graal. This is not to be confused with the Graal VM. Why Oracle decided to call these things the same name, I don't understand, because technically Graal VM should be the substrate VM, because that's the project that it came from. But they decided to call it Graal just to confuse you. But don't be confused about this, because the Graal JIT compiler is a replacement for the C2 JIT compiler in Hotspot, and it's designed to be much more modular, much more easy to add features, and give you better performance in terms of the code that's generated by the JIT compiler. Last one there, heap allocation on alternative devices. This was something that was contributed by Intel. They've been working on the idea of non-volatile RAM that's as fast as dynamic RAM. So they wanted to be able to allow people to put their heap on non-volatile RAM as well as dynamic RAM. JDK 10 had a number of new APIs. There are actually 73, but I didn't bother writing them all down. Most of the ones that you get in JDK 10 sort of relate to unmodifiable collections. So the list, the set, and the map interface all have a new method, static method on them called copy of, and that takes a collection and returns an unmodifiable version of that collection. So you can't change the elements in it. Similarly, for the Streams API, the collectors utility class now has 3 new methods, 2 unmodifiable list, map, and set, which will return you an unmodifiable collection from your input stream. Optional has a new method, which is or else throw, which is exactly the same as get. Why they added that, I'm not quite sure. It's something to do with the fact that it's more expressive, I guess, rather than get. But there you go. So it does exactly the same thing as get. JDK 11. So this is the current long-term support release in terms of the OpenJDK. And JDK 11 didn't have quite so many things in it. So again, 6 months of development work. One of the things they did here was to add the idea of launching a single file source code. What does that mean? Well, if you look at JDK 10 and earlier, there are 3 ways that you could launch a Java application. First is from the class path. So you can do Java minus class path, where your classes are, and then main or whatever, and start your application. You can do it from a jar file, so you can do Java minus jar, name my jar file, great. Or you can do, with the module system, you can do Java minus m, name the module that has your main entry point. In JDK 11, there is a 4th way of starting your Java application. You can launch from a Java source file. What you do is you say java factorial.java 4. JVM will look at that file and say, no magic number at the front, which says this is a class file. So in this case, it's a Java file. What it then needs to do is run the Java compiler on that, generate a class file, and then execute from that class file. Really, the idea behind this is to make it simpler to get started with Java. Because if you think about it, writing your first Java program is actually quite complicated in terms of all the steps you have to go through. So by simplifying it to the point where you can simply say, okay, here's my Java code, just run it, it's sort of more like a scripting language, but not quite. And you can take this a little bit further. So you can use Shebang support, and you can put your Java code in a file. If you make the first line of that file #bang, and then where the Java executable is located, add the source flag to say which level of source code you're interested in, make that file executable. Let's say you're on a Linux machine, then you can just do /factorial4, and the operating system will say, aha, run the Java executable on the rest of this file. That then analyzes it, figures out, okay, run the Java compiler, then execute it from the JVM, and like I say, it's almost like a scripting language, but not quite. Again, a few selected JEPs that went into JDK 11. First of these is nest-based access control. And this is a piece of work that's been going on in terms of a bigger project called Valhalla. And I'll talk a little bit about that at the end. But essentially, from a developer's point of view, this makes no difference to you. Because what it's about is when you have inner classes can actually refer to private members of the outer class. And how they do that has been changed to make it more flexible from the JVM's point of view and easier for the project Valhalla to do the things that it needs to do. Second thing, dynamic class file constants. I find this very confusing because surely it's either dynamic or it's constant. It can't be a dynamic constant. But that's what we have. We have dynamic class file constants. Now, okay, I'm being a bit facetious here because what this actually is about is the class file has constant values in it. And for people who are writing compilers for languages other than Java that compile into bytecodes, then there are certain situations where having those values fixed is less than ideal because of the way that the language and the compiler works. So what dynamic class file constants is about is effectively giving you the same as you've got as a final variable in Java. So you can set the value once and then it's fixed. So it's dynamic in the sense that you can set it at the beginning, but it's constant after that. The epsilon garbage collector is a new garbage collector that's been added to the JDK. Interestingly, it's a garbage collector that doesn't collect any garbage. So you think to yourself, what's the point of a garbage collector that doesn't collect garbage? And the answer is that this was actually contributed by Alexei Shipilev, who works for Red Hat, and he's working on the Shenandoah garbage collector. The real idea behind this is to allow people to test garbage collectors and see what the performance impact is. So you run your application with the epsilon garbage collector. Hopefully you don't run out of heap space. You see what the performance is like. Then you run again with the new garbage collector and you see what the difference is, so you know the impact of the garbage collector on your application. Some people think this is a good idea for AWS Lambdas or the massively inappropriately named serverless computing, so that you could have very short-lived processes and not bother with garbage collection. We'll see if that works. HTTP client, this was something that was introduced in JDK 9 as an incubator module, so it wasn't part of the standard, and it allowed people to give feedback about what they thought of the way that the API worked. Now, because the feedback has been received and processed, HTTP client, or HTTP 2, is now part of the standard. Transport layer security version 1.3, that's just upgrading to the latest version of TLS, so that's now included. And yet another garbage collector, the ZGC, or as the Americans like to call it, ZGC. This is an experimental low latency garbage collector designed to kind of eliminate as far as possible garbage collection pauses from your application. Again, JDK 11 had some new APIs in it, and so I picked out a few here. So there's the ability to create a null input stream and a null output stream, or a null reader or a null writer. And I must admit, I looked at this and I thought to myself, I've been programming in Java for about 24 years, never needed these APIs. So why do I need a null input stream that I can read precisely 0 bytes from, or a null output stream that I can send as much data to as I like and nothing happens? Well, it's kind of like /dev/null. And there are certain situations where if you're doing a more functional style of programming with streams, that these can actually be useful. So that's why they've been added. Optional has yet another method called isEmpty, which is the opposite of isPresent. String has some new methods. So this is quite nice because it's come in for some updates. So the first of those is isBlank. I'm not going to tell you what that does because it's pretty self-evident. There is also a new method called lines, which will return a stream of lines if your string has line breaks within it. So if you've got line breaks, then it'll separate it up and give you a stream of the individual parts of that string. Repeat does the obvious and repeats a string a number of times. And then we've got these three methods called strip, strip leading, and strip trailing, which allow you to remove white space from either the beginning of a string, the end of the string, or both ends of the string. The observant amongst you will look at that and go, well, hang on, we already have trim. What's the difference between trim and strip? And the answer is how they deal with white space. Trim uses a very basic idea of white space, essentially space, tab, new line, whereas all of the new ones, strip, strip leading, and strip trailing, use the Unicode definition of white space, which includes many characters that you probably never realized were white space, things like vertical white space, stuff like that. Well, I think my favorite feature in JDK 11 is that predicate has a new method, a new static method called not, which takes a predicate. And if we look at an example of that, let's say I've got a method here I'm filtering, and I've created a Lambda expression which says I want to filter out blank lines. So I could do it that way, but if I use the predicate not method, I can do it this way, and I can say filter predicate not string is blank, and use the method reference rather than the Lambda expression. And if I do a static import on predicate not, I end up with filter not string is blank. It's just a bit more readable, just a bit more clear in terms of what's actually going on in your code. JDK 11, big thing here was that several modules were removed from the JDK. So this goes back to the sort of idea of deprecation and starting to remove some of the previously deprecated APIs. So there is this aggregator module called java.se.ee, and that contains really the sort of enterprise Java APIs that have kind of snuck into Java SE. So these are the modules that have been removed. Corba is gone. Anybody here using Corba? Nobody, that's good. Okay, so that won't cause a problem then. I don't think there's anybody developing new Corba code, so that's probably really not a big issue. Beans activation framework, that's also gone. JAX-B, the Java API for XML binding. Anybody using that? A couple of people, okay, a few people using JAX-B. And the one that seems to catch out quite a few people is JAX-WS. So this is Java API for XML web services that use SOAP rather than RESTful web services. Anybody using JAX-WS? Yeah, a few people as well. Well, the answer to everything except for Corba is pretty straightforward. If you do still need those modules and you're using Maven, then it's pretty straightforward. You can just change your POM file, and there are reference implementations that you can get from Maven Central, so it's easy enough to fix that. Also, if you want to, you can download the modules from the reference implementation of the specific JSR. JDK 12. So what do we get in JDK 12? Well, we have our first preview feature. Now, preview feature is an interesting idea, which is possible because we have this faster release cadence of every 6 months. What a preview feature does is it allows the developers of Java to add a new feature to the language or the platform without making it part of the standard. So that way that if people want to say, well, actually, we don't quite like the way this works, then changes can still be made, or the whole feature could be removed if everybody really doesn't like it. And then once it's settled and everybody's happy with it, it can be made part of the standard. If you want to use these, you have to turn on a command line flag to say, I am using the preview features, and tell it which preview feature or which version of preview features you want. In terms of what we're getting here, we have switch expressions. Now, if you look at Java up until now, we have the switch statement. So a switch statement allows us to do something, but it doesn't return a result. So we can't assign the results of a switch statement to a variable. What a switch expression allows us to do is exactly that. It will return a result which we can assign to a variable. The thing with switch statements in Java up until now is that the syntax has been a little bit clunky, I suppose is a good way of describing it. And the reason for that is that they copied the syntax for the switch statement from C. And C is a systems programming language where there are certain things you might want to do with a switch statement which are more suited to that kind of programming, which don't necessarily make sense in a Java application level programming. So certain things like the fact that you have to have separate case statements for each thing that you want to have within your switch, and the fact that you've got to remember to put a break at the end of your switch block, otherwise it drops through into the next one. And I'm pretty sure, because I know I've done it more than one occasion, I have forgotten to put a break statement in, and suddenly you get this bug where you think, that cannot possibly happen because it shouldn't do that. And then you kind of go back and you look at it and go, oh yes, I forgot to put a break statement in, and then everything works. So here's an example of how we would use switch in Java before JDK 12. What I want to do is I simply want to switch on a variable, in this case the day of the week, and I want to assign a value to another variable, in this case the number of letters in the name of the day of the week. And so I can do this by saying switch on day, and then case Monday, case Friday, case Sunday, number of letters is 6, and then if it's Tuesday it's 7, and so on. That works, it's fine, but there's an awful lot of code there for what we're doing. There's lots of lines, and we have to have separate case statements and all of this kind of thing. If we use the switch expression, we can simplify that really quite massively. So we end up with this. So now we simply say number of letters is the result of the switch expression, meaning that we only make the assignment once. So that's good because we could potentially forget to put our assignment in each of those case blocks. So now we're only making the assignment once, nice and clear. Switch on day, then we've got case, and I have to say I find it amazing that the engineers who worked on this have done some research and they found this very hard to understand concept, which is called a comma-separated list. So that now we don't have to have separate cases. We can do case Monday, comma, Friday, comma, Sunday, and put it all on the same line. Wow, only 25 years to get to this point. They then borrowed some of the syntax from the Lambda expression, so they used the arrow, and the right-hand side of the arrow is the value that's going to be returned from the switch expression in that case. So Monday, Friday, Sunday is 6, Tuesday is 7, and so on. And if we want to, we can throw an exception, that's fine. So as we can see, it makes it a whole lot more succinct, a whole lot easier to see what's going on. We can combine the old style and the new style. So we could say case Monday, case Friday, case Sunday. In this case, we're going to do break and then give it a number. And that way it will return 6 from that case block. Yeah, it's kind of interesting, but I'm not sure I would use that. And then you can get really complicated and you can actually create blocks of code where you can say case 1 and then you have a block of code. The important thing in this example is that for case 1, I've created a variable x, and for case 2, I've created a variable x. In the old style of doing things, you couldn't have done that because the scope of x would be across the whole of the switch statement, so you wouldn't have been able to do that. So now, with the new style, you can actually have x in both case 1 and case 2. Few selected JEPs in JDK 12. The inclusion of Shenandoah garbage collector now as an experimental GC. This is the one that Red Hat have been working on for a long time. Alexei Shiplev, Christine Flood, people like that. G1 has come in for some more updates, a couple of things there. One is abortable mixed collections, and essentially what this allows the garbage collector to do is to monitor how long it's taking to do garbage collection. And if it feels that it's going for too long and the pause is too big, it can actually sort of say, okay, I'm going to drop out of doing this and get to a safe point where it can stop doing garbage collection and allow the application threads to continue running. Returning unused committed memory, that's good for if you're running multiple applications on the same machine and you've got a JVM where the heap size has grown, but now the amount of live data has shrunk quite a lot, then the JVM can actually return unused memory to the operating system and allow other things to use that. JVM constant API, that's related to the dynamic constants, so now you have an API that you can actually use to access those. And default CDS archive is again related to the class data sharing, so that you don't have to generate the file for the default, or not the default, but for the standard Java classes. Streams has a new collector in JDK 12. I like this one. So this is a collector called teeing. And what teeing does is it takes two collectors and a by function. And I've given you a nice diagram here to explain how it works. We take the input stream and we duplicate it so that we've got two parallel input streams. And we pass each of those input streams through the two collectors that we've defined as the parameters and pass the results of those collectors as inputs to the by function, which takes two inputs and generates a result. So the by function then creates a result. To look at a simple example of how that would actually work in practice, what we could do is we could take a stream of numbers, 145217, pass that into collect, and use the teeing collector, statically imported, and then we could say, okay, my first collector is summing double. So I want to take all the elements on my input stream and add them up to get a total. The second collector I'm going to use is counting, so that will count how many elements I have on my input stream. My by function takes the sum and the number of elements and then simply divides one by the other to give me the average value of those input elements. Now, clearly I could have done that with a single method call, but it gives you an idea of how that can be used for more complex processing. So it allows you to do that kind of thing. JDK 13. So this brings us up to date in terms of where we are with released JDKs, the current version. Now, JDK 13, I will admit, was fairly light on new features, but we did get text blocks, again, as a preview feature. And the idea behind text blocks is to make it easier to have text that go, well, not easier, but possible to have text that goes across line breaks in Java. Because up until now, when you create a string, you have to have a string which only fits on one line. And either you have to sort of concatenate strings or you have to add in escape characters and so on. So text blocks allows us to do something like this. So we can say, okay, I want a web page, and I'm going to start the text block with 3 double quotes. Everything after that, up to the next 3 double quotes, is treated as a string, including line breaks, including odd characters, whatever. So we can do something like this, where we can create some HTML code, and all is good. Obviously, if you wanted to have 3 double quotes inside your string, then you just have to escape at least the first one of the 3 double quotes. But you can escape either the first one, the first and the second, or the first, second, and third, if you really want to. Now, the interesting thing about this is that we also have to understand the concept of incidental white space. The reason for that is that in terms of formatting, what we obviously want to do is to have the ability to indent the text that we want for our string, but we don't necessarily want to include that indentation as part of the string. So the incidental, if we print out what that actually generates, we'll see that it doesn't have all the extra white space on the left-hand side. And the reason for that is the position of the closing 3 double quotes. By putting that underneath the closing HTML tag, what we end up with is incidental white space, which the compiler will eliminate from each line so that the text actually ends up lined up on the left-hand margin. We do, however, get an extra blank line. So if you don't want that, you can move the 3 double quotes onto the end of the string, and that will still work. The other thing you can do is, if you want to, you can actually move the 3 double quotes to the left, and that will reduce the amount of incidental white space that's removed, effectively adding some padding before the text on the left-hand margin. Switch expression. Hang on, I've just talked about the switch expression. Why am I putting this back up again? Well, this is one of the great things about having a preview feature, which is people can give you feedback and say what it is they don't like about it. And what people said was, well, hang on, you're using break with a number to indicate the value that's going to be returned by the switch expression. And that's okay, because it technically will work. You can break to a label, but a label can't start with a number, and it can't be just a number. So from a syntax point of view, that will work, but it's rather confusing by having break overloaded for both a value that's being returned from the switch expression and the ability to break to a label. So the decision was made that now the next preview of switch expressions will not use break, it will use yield. So now you yield a number rather than breaking a number. JDK 14. Right, so this brings us up to what we're going to see next month. JDK 14 is really good. I really like some of the stuff in JDK 14 because there are 3 big features that are going into JDK 14, 2 of which are at the language level and 1 of which is at the JVM level. The first of these is records. Records is a preview feature again, and this time we now have the ability to create simple data classes without all the extra code. Because if you think about it, if we wanted something like a point, which had an int x and an int y in it, you end up by creating a class, then you've got your instance variables, int x and int y, then you've got to create a constructor, which takes int x and int y as parameters, then you've got to assign this.x equals x, this.y equals y, you've got to create accessor methods to say get x, get y. Lots of code. Now it's one line. So we can simply say record point int x, int y. And the net effect of that is to create a class. That's not actually exactly how it happens, but the net effect is to give you a class which gives you the ability to have 2 variables in it, x and y, that you can assign through the constructor, and then you can access them through the get methods. Few things about records. The overall idea of this is to have final values. So there are no set methods generated. You can't change the values once they've been set because it's designed that way. Now, some people don't like that, but this is the way that it's been designed. The second thing with records is that you can go a little bit further. So there is flexibility in how records work. Example of that is that you may have a situation where you need a constructor that's going to do more than simply assign the values that you want for that record. In that case, you can provide an alternative implementation, and you can do it in a simplified way. Here I've got the idea of a range, which is going to have a low value and a high value. But I need to test that the values being passed to the constructor fit into that idea such that the low value is actually lower than the high value. In that case, I can say, okay, I need a constructor, which I don't have to specify in the same way as I would normally, because there's no point in specifying the parameters of that, because those are fixed. So all I do is I say public range, and then I can put code in there which says, if low greater than high, throw a new illegal argument exception. Records are flexible, so if you want to replace the implementations of things like toString or hash code, then you can do that as well. Anything that's in the class, you can replace that if you want to. But you can't add extra variables, you can't add other things. So it's a nice piece of code in terms of simplifying how things work. Pattern matching, another preview feature. Now this is pattern matching for instance of. And the reason for this is that if you think about, you have situations where you're passed an object, but you don't know what the type of the object is. And you end up doing a test on the object, say, is an instance of string, for example. Once you said, yes, it is a string, in order to use it as a string, you have to do an explicit cast to a new variable to say, okay, this is a string, use it as a string. Now, with pattern matching, what you can do is something like this. You can say, if obj instance of string, and then specify a variable name, string s. And then what will happen is that in the scope where that makes sense, you can use s as a string. So you're not doing an explicit cast. All you have to do is say, okay, within the true branch of that if statement, I can say system.out.println s.length. And s is valid in that case. However, in the else branch, because clearly the object that's being passed in is not a string, then s doesn't have valid scope. So we can't reference s because it isn't a string, and so we can't use it. So that's a simple example of using pattern matching in this case. There are some slightly more flexible things you can do here. So for example, you can do something like this. You can say if obj instance of string s and s.length is less than 4, then do something else. So the scope of s can be used within the if statement. So in the conditional of the if, you can use s in that way. But be careful, because in this case, you're using an and. And because you're using an and, the left-hand side has to be evaluated and has to be true in order for the right-hand side to be used. So it makes perfect sense in this case. What you can't do is something like this. You can't say if obj instance of string s or s.length is less than 4. The reason you can't do that is because both sides of the or statement, operator, use the right term, both sides of the or operator have to be evaluated in order for that if statement to be processed. So if obj was not an instance of string, then it would still try to evaluate s.length, which wouldn't make any sense. So that won't compile. And then you also get some interesting scoping for the way this gets used, because you can do something like this. You can say, if not obj instance of string s, return. So you return after that, s is still valid, because it makes sense, because if it's not an object, not a string, we've returned. So everything after that means that object is a string, so we can reference s. Some people are I've seen some pushback in terms of feedback on this, and people are not totally convinced about how that scoping works. But for me, I like it because it does make sense. It's very logical in the way that it's laid out. So you do get everything working quite nicely there. And there's some interesting ideas for how this can be extended further. If you look at JDK 15, well, actually not JDK 15, but there's another JEP that may make it into JDK 15 that will extend this even further. Yeah. Helpful null pointer exception. This is my favorite feature. How has it taken us so long to get to this point? Has anybody here never had a null pointer exception? Yeah, of course, silly question. Yeah, we've all had null pointer exceptions. And most of the time, if you look at where the null pointer exception happens, you go, oh yeah, I didn't assign a value to that or whatever. But sometimes it's a bit more complicated because we do something like this. We chain references and we say a.b.c.i equals 99. We get a null pointer exception at that point. And then it's tricky because What caused the null pointer exception? Was it the fact that A was null, so we couldn't reference through it, or was it B that was null, couldn't reference through that, or C that was null and couldn't reference through that? We either have to use the IDE and we have to use the debugger, or we have to then start separating out things and doing print statements and all sorts of stuff like that. In JDK 14, yes, finally, A.B is null. So we immediately know what the problem is, and then we can go and fix it. So like I say, this is my favorite feature in JDK 14. Okay, just briefly at the end, I'll talk a little bit about some of the longer term JDK futures, because we're seeing a nice gradual change in terms of new features being added to the language, new APIs and so on. What about bigger things that are going into Java? And there's a couple of things that are interesting to talk about. First of those is Project Valhalla. And I kind of mentioned this a little bit earlier on with the nest idea. The thing with Java is how we store information. And when the developers of Java started off right at the very beginning, they decided that they couldn't treat everything as an object and make Java a truly object-oriented programming language. And the reason for that was performance. Because if they treated everything as an object, then they couldn't get the performance they needed for the language. To get around that, they included primitives. So we have int, float, double, and so on. The problem with that is that there are situations where we might want to use a primitive, but we can't because of the way the language is designed. So something like ArrayList of int will not work. We need a type rather than a primitive, so you have to use integer, which is a wrapper class, and then that has all the issues of the fact you've got to auto box the value that you want into a new object, put that into your array list, then you've got to unbox that when you need the value out of it again, and you've got to do garbage collection on all that sort of thing, and everything like that. So what Project Valhalla is going to do is introduce the idea of an indirect projection. And so we'll have something like this where we can have an array list of optional int question mark. So this is still very much a work in progress, and there's various things going on in terms of trying to figure out all the syntax and so on. It is a big project, and it is still, I believe, some way from completion. The other thing is that we were going to have what we call value types, but now they've decided not to call them value types. They're going to call them inline classes. And inline classes are going to require 2 new bytecodes in the JVM. So default value and with field will be added as part of this. And the idea behind this is that it codes like a class, works like a primitive. Because what we want to be able to do is treat something like this so that we can store it as if it's a primitive value, but still reference it like it's an object. And so this is the idea behind this. Essentially what we're dealing with is truly final values inside a class. And you might think, well, we already have final values within a class. You just simply say, final int I, and you assign a value to that, and it's fixed. Except it's not, because if you use reflection, you can actually change a final value even though it's final. With inline classes, they will be truly final. It will not be possible to change them. So it looks like a class in the sense it has methods, fields, can implement an interface, can use encapsulation, can be generic, but it cannot be mutated. And because of that, it can't be subclassed, and you also can't synchronize on it. Last thing to talk about is Project Loom. This is, again, looking at how to make life easier for massively multi-threaded application code. We have the idea of threads in Java. We have had that right from the very beginning. But a thread in Java maps to a thread at the operating system level, which means that when you have thousands, tens of thousands, a million threads, it just doesn't scale because the operating system can't do that. What Loom's going to introduce is, well, they were going to be called fibers. Then they were going to be called lightweight threads. Now, as far as I know, right now they're being called virtual threads. That may change in the future. But the idea of a virtual thread is it's that you can have a single operating system thread with multiple virtual threads that map to that. And the JVM will be responsible for context switching and scheduling of the virtual threads onto the operating system thread. They're going to use the fork join pool scheduler that was introduced in Java SE 7. Essentially, the work that they're doing at the moment is adding continuations to Java. And a continuation is essentially the context for a thread to be able to run. So the values you have in your registers, the instructions you need to run, and the state that needs to be reloaded to get that to work. The idea is they'll be much lighter weight than threads, use less memory, and have close to zero overhead in terms of task switching between the virtual threads on an operating system thread. Last thing I'm just going to mention, because I work for Azul, so I'm going to talk a little bit about, well, for a minute about Azul's Zulu Java. We have a build of OpenJDK, and it is free. So if you want an alternative for OpenJDK binaries, then you can go to our website and you can download them for free. We run the TCK on it, passes all the tests. We have a wide variety of versions, 7, 8, 9, 10, 11, 12, 13, and we have 14 and 15 in early access. Wide platform support, 64-bit versions for Windows, Mac, and Linux. For people using older operating systems like Windows XP, there's also Windows and Mac, 32-bit, and ARM 32 and 64-bit. Zulu Enterprises, if you want commercial support, then please come and see us at our booth. And so just to summarize, Java continues to evolve. I think it's really good to see how quickly we're getting new features in terms of Java. So the 6-month release cadence means that we are getting access to lots of new features very quickly, far more quickly than we ever had in the past. And there are lots of ideas for improvements in the future, both small and also big things like Project Valhalla, Project Loom, and so on. And so with that, thank you very much.